It's a very important topic that Jerry spoke about, because it's a bugaboo of mine that people understand the consequences if things weren't done right, and going forward if they're not corrected. Two cars have an accident out on the street. Typically people think, one or the other person is at fault, or perhaps there's some shared fault, but it could very well be that there's some liability that falls to the agency, because that's a two-way left turn lane that maybe should have needed a median. Car slowing to make a right turn gets rear-ended by the car behind him. You'd think that the car behind would be charged with fault, but maybe there wasn't sight distance, maybe there was an over vertical, maybe there was some liability that can be attributed, and a lot of people try to apply that tort liability to the public agency. So it is a very important question to understand the consequences of designing things incorrectly or poorly. Give Karen, let's get our next speaker here. Dr. Karen Dixon is a senior research engineer, program manager for the roadway safety program at Texas A&M Transportation Institute. She earned her bachelor's from Texas A&M and a master's and PhD from North Carolina State University. She's a registered professional engineer in Texas and Arizona. Specific to this conference, she is chair of the TRB Highway Safety Performance Committee. She's also a member of the TRB Operational Effects Geometrics Committee. She is, of course, co-author of both the 2014 Access Management Manual and the 2016 TRB Access Management Application Guide. I was the FHWA representative on those teams as well, so I got to know Karen. I got to know her deep commitment and involvement in this, and she really is a research wonk. I hope she doesn't mind me saying that, but she gets into it when she wants to talk about these issues, and she's going to tell us a little bit more about the application guide. Karen?
So I have this interesting trend going on this summer that I've noticed when I go to conferences and speak. So far, without fault, I'm always speaking right before lunch. I'm not sure if that's a message that's being sent to me, but I'm getting it. I want to make a correction earlier in our little lightning round thing. I was drawing a blank. I actually wasn't drawing a blank. I was trying to remember whether or not University of Arkansas was on our AMAG team or our Access Management Manual team, because Jim was the chair of one and a member of the other. And so he was on our team for this one, and he chaired the panel for the Access Management Manual, and so that was my oversight. But so University of Arkansas was one of the key members. So if you see him, tell him I fixed that, so he won't be mad at me. Hopefully he's not. But I was actually a faculty member at Oregon State University when this research started, and then ultimately I came over to Texas A&M to the TTI, and so both universities ended up playing a role on this particular project, and as I mentioned earlier, we also had Kittleson and Huntington Traffic Solutions. We saw this in the preview, so I'll just skip over real quick, just reminding ourselves that the purpose of this is how to, and that's the primary goal for the AMAG. Not to provide new content, but just to tell you how to apply it. So for the AMAG, I just thought it'd be helpful to go over very quickly what the general document content looks like, and then ultimately we can talk a little bit about the tools that come with it. You saw this nice, easy to read graphic. They created one for the Access Management Manual. I did not have one created for the AMAG. I tried to dig my heels in on it because I thought it was too much stuff for one graphic. But there is something to be said for having one graphic where you can figure out which chapter you go to quickly without having to look at a table of contents, and being visually oriented, as engineers often are. I think it serves a very good purpose. But I want to just talk a little bit about the general configuration of some of the other content in the manual. So one of the things that we did, I tasked Mark Butoric with this actually, because he was also a member of our team, was to come up with just a general structure of each individual module that we presented. So we had modules on all these different characteristics, like turn lanes, for example. And I thought it'd be helpful if from module to module to module, where appropriate, they had kind of a consistent structure and format. And so each module starts out with a definition of whatever the problem is that you might want to learn a little bit more about how to apply. The purpose then of the section and addressing that. And we also tried to put in a guidance for users, all users, and then talked about application issues and vehicle issues. When I say vehicle perspective, the other user perspective primarily was bicycle and pedestrian, but as fitting, it was also transit or heavy vehicle. Also was often included in that. And then we gave some related content references and, of course, try to show some example problems and then the cited references. So each one of these, where appropriate, that content was included. For the first section, which is kind of the general overview, the general concept, it had four chapters. The most important one, in my opinion, was when and where to apply access management. I think, of course, being an access management person, I would say everywhere, but there might be some boundaries about how you apply the access management, and so that was what we were trying to get out there. How you might then apply it to the general functional classification as well as what we called access management categories, and then some alternative strategies that you might consider. So that was kind of in an introductory section of the manual. Next, we had a policy-related access management section, and we talked about guidelines versus standards. We had talked about legal authority for access management. That was Chapter 6. And in that process, we ran into a question of a definition that still I think gets mixed up, and that is when something is accessible versus has access. And of course, accessible to the ADA community would mean that it's, the grade is appropriate, it's that grade, it's designed for wheelchairs, it's got visual and sensory cues, whereas access management is slightly different. So we tried to get some clarification on that issue, and we also tried to talk a little bit about the term variance versus deviation, which is in Chapter 7. Now, he wasn't on the team. Virgil Stover, though, that Christine mentioned earlier today, she said our father of access management, so I'm going to have to fix that because I keep on calling him granddad, but he's a wonderful friend. And he was nice enough to write up an opinion piece for this particular issue on variations and deviations. And so we've included that as an appendix to that particular chapter, straight from what Virgil wrote, just to see his take on how you clarify those two particular issues. And then other chapters we had were permit processing and economic impact of access management strategies. I might mention that Dale Huntington used to be the access management manager for the Oregon Department of Transportation, now with Huntington Solutions. And he used his experience from that capacity to try and help us incorporate some of this information in this particular section of the manual. Section 3 was local access driveway design. And of course, it talked about driveway design and geometrics and driveway throat length guidelines. And both of those were penned by Jim Gaddis, as is appropriate because that was squarely along the recent driveway research that he did. And then for the corridor design section, we talked about a variety of corridor issues. We have a chapter on unsignalized access and signalized access, including talking a little bit about the progression issue when you have dense access spacing, which we know is, of course, a problem. We talked about roundabout access, in particular, what the measurement point is for roundabout access when you're thinking about cues and other characteristics of the access point as opposed to traditional intersections that we've conveniently used. And then we looked at median, unsignalized median opening design, U-turn lane requirements, and of course, access management in the vicinity of crossroads at the vicinity of interchanges. A couple of these have subsequently generated additional research efforts that are ongoing. And then we had kind of a site design section. Actually, that's how I started my world out in engineering, I was a site designer for many years. I was very young, Ingrid, very young when I started. So Chapter 19 talks about special site circulation and access techniques, and Chapter 20 is summarizing land use considerations. Of course, we don't have a one-size-fits-all for urban, rural, or suburban. Those are all unique characteristics with their own unique needs, and so that's trying to identify and help specify how you would apply to those. Then we have turn lanes included in Chapter 21 and Chapter 2 for both left turn and right turn. And we recognize that that is something that varies dramatically from agency to agency on how they design their turn lanes. And so we also try to present some flexibility on how that could be addressed. Then our final section of the AMAG was Other. Don't you love it when you can't come up with a good title? Other. It seemed to do the job. Other access management, which included issues like human factors, which maybe should be chapter number 1 if I knew more about human factors. But human factors and access management is kind of an untapped area that we really need to start focusing a little bit more on, unless all of the automated vehicles are going to take over. And until 2053, we need to start focusing on them, right? Localized access management, quarter considerations, and system-wide. Because those are not the same thing. You know, localized would be a project level or specific location. System-wide, of course, would be looking at your larger network. And those issues might be different. You might sacrifice access on one for, say, bicycle mobility and then transfer that access to a parallel corridor. And so you need to think of the larger picture when you're looking at that particular section. And then we talked about communication strategies. Kittleson Associates often give public hearings. You saw how dynamic Mark is in front of an audience, and so they have come up with a wide variety of clever ways to try and communicate their expectations to the general population. This is particularly important with access management. We often get pushback, and in some cases, access management projects get stopped. Medians, for example, in the state of Oregon, they had an issue come up where they were placing medians at diamond interchanges to try and prevent what I will call the up and over maneuver, where a car drives off the off-ramp, say there's congestion or something, goes across the cross street and back down. So their thought was, well, let's put a median right there at just select locations, 1 or 2 locations where they were having a problem. Well, what happened was that they had a very robust manufactured home industry in the vicinity. And the manufactured homes, once they were mounted on their trailers and being towed, would not fit under 16 foot 6 inches or whatever the lowest clearance was on their bridges, and they needed that up and over. And so rather than articulating that particular concern for that region, what ended up happening is they went to the local congressman, who then tried to create a project or a bill that would completely stop the construction of all medians within the state. And it actually stalled the construction of medians for 2 years. And then ultimately, they put some boundaries around it, and they've, started building medians again. But, there are little issues like that that are very specific to a jurisdiction that you have to give some strong consideration for. And you might make exceptions in some of those cases. So how you communicate something like that to the public is very important for them to understand, don't need to do it everywhere. It's just these 4 locations where there's some special consideration. So that chapter gives you some ideas. And then finally, the existing AASHTO design standards and how they relate to access management. And when I say existing, I meant the 2011 AASHTO Green Book. I believe that by the end of this summer, we're promised we'll have a new Green Book, and so hopefully they've continued this interaction between the 2 documents. So I mentioned earlier that I had, in addition to having the 2 documents linked together, we have you can buy a USB that has that capability from TRB. And an extra thing that's on that USB, and it's also on the DVD for the AMAG, is a series of self-calculating spreadsheets. One of the things I learned a long time ago in my researchy world is that I don't have all the answers, but I just have lots of questions. Lots and lots of questions. And sometimes when I'm working on an analysis, what's been the standard method that I've seen for many years, some other agency has a great way to handle it. And so we try to keep these to where they were very flexible. You could customize them to fit your specific local needs. There's nothing locked on them. And that was our intent on purpose. The goal was to make them something that someone could take, they could adapt to their local agency if there's a modification that needed to be made. So I showed earlier, this is the categories that we had, the upstream and downstream corner clearance, decision site distance, intersection site distance, and then the left and right turn. I should also mention that one of the key contributors to this effort was a young lady named Lacey Brown. She works for DKS in Oregon currently, and she is phenomenal. She was one of my students. She's a phenomenal young access management person, a new member of the Access Management Committee, I understand. So I think that merits some acknowledgement. So I know you can read this because I, of course, can. No, yeah. I can read the title. I have this up here for you to see as you're zoomed out what the format or layout looks like on one of these spreadsheets. So typically there will be a graphic that updates itself. And then there's usually a series of input and output computations that are kind of stacked to the right. So just to kind of zoom in, we're going to start at the top right and just take a closer look at that. That is actually, on this particular one, which is the left turn lane, that's actually the minimum storage length input. I'm just trying to see what time it is because I don't see one up here. Okay, okay, 15 minutes, good. And so this one basically is input information that you would like to put in. And each of these spreadsheets kind of is set up this way. Anytime that we use something that requires you to go and look it up, we either will have a separate tab with lookup tables or we'll point you to a source of information as well. The lookup tables have, for example, the Access Management Manual 2 and AMAG information in them, but we still document where we got it in case you want to just go and confirm that we're telling you the truth. So all of these things can be edited. We'll show you one of these in just a minute, but then it will calculate something and puts it in a box at the bottom. So for example, this one calculated your minimum storage length and told you the length of that in feet. The next one would then be the minimum breaking in the stacking of that graphic that we saw. And this one, all it really needed, in addition to the information it had before, was design speed. So you tell it that, and it tells you what your minimum breaking distance would be. Then finally, it asks, well, how do they transition? Do they have a taper, or sometimes they have some other curved configuration? But if it's a taper, then is there a rate? If it's something else, it might be a distance. I believe Florida, for example, has just adopted a standard distance that they use typically, depending upon the number of turn lanes. And then what the width of the turn lane is, and then it will give you the calculated value there. And then we'll use the information we just saw before, and we'll come up with what the perception reaction distance is as well. So that's an additional facet that it provides for you. And then I mentioned there's always a graphic, and then these numbers just self-populate based on the numbers you saw in the other. So there's nothing rocket science about this. These mostly are equations that have been around for years. The purpose of this is just twofold: to very quickly be able to just run a sample calculation and make sure you're in the ballpark, and then to have a source of documentation, which is very important when you're doing these sorts of analyses. So I'm not quitting yet, sorry, if you were getting your hopes up when you saw that. Y'all weren't, were you? Okay, good. Because you never know. All right, so let's see how this works here. I do not use an Apple product, so I'm not sure how to zoom in and out on this one. Let's see. The plus or minus? Oh, down here, yeah. This guy here? I don't know my right from my left, clearly. Here we go. There we go. Thank you. All right, so this one you can see is kind of an instructions page. And just basically the left side, and each one has an instructions page. They actually will have 4 tables, or 4 tabs, excuse me. Though when you download them from the DVD, you might just see 3. There is one that I call construction. Normally I have it called construction, please do not delete this, but it's just used for calculations. I have it visible here just so you can see that it is in fact here. It's this 4th tab here. It's just a series of query tables so that, you know, when it's looking things up, it has that information to go to. In the instruction tab that we have on each one, I have some information about color coding. So, for example, the colors that are used, they aren't showing up very vividly here, but there's kind of a bluish and kind of a peachish color is what they look like here. But what I've discovered My brother-in-law is colorblind, and so he walked up behind me while I was working on this, and he said, "Why are you making all of your boxes gray?" I wasn't. They were kind of bright green and red, which apparently I did not know, even though, yes, I know what you're thinking. Traffic signals are green and red, right? What were we thinking? So any of you colorblind that have this issue, can't see the difference between green and red? Yeah, good. Well, he is, apparently. I don't drive with him anymore. I understand he tells me he's overcome it, but I'm just not willing to go there. But what I can tell you is that I went in and I queried what are the color combinations I can use for someone who's colorblind, so that we could at least make colors that would show up in our spreadsheet tool. So the colors I've selected here intentionally are designed in such a way that it will allow someone to be able to see. So here, this is that left turn bay one that we saw before. So this is, you zoomed out for the spreadsheet. I'll show you a little more functionality in a minute with one of the others, but just to see the structure of the left turn bay tab in this particular one, then the next one is tables. And if there's anything that when we're doing the analysis I felt needed to have someone just confirm for their particular jurisdiction, then I usually highlighted the table. So if it was just a standard table or some source like that's been around a while, or one that I could recalculate, but I wanted to still cite the original author, then it just looks like a normal table. But if it was something that was either under the works, it was in draft, it was something that I thought would be changing, or I just wanted to make sure that you customized it for sure, or at least explored it, then I highlighted it. All right, so this is kind of the turn lane one, and as I mentioned, I could change any of these values. For example, I could change my design speed here, which was this one. All of these, by the way, have like little pull-down tabs. So I used the design speeds that we had available for us. I could change that. And then if you just kind of watch over here on this side, you can see that the values start updating. So, or now I changed it to 50. You can see this number here, for example. You maybe can't see it, but it's 425. If I were to go then and change this speed back to say 40, that number changes to 75. So that's just typical of all these values. They all just update like that. So this is the left turn one. Very quickly, I'll show you one more, just so you can kind of get a flavor for what these look like. So this one is the decision site distance one. All of them have the same configuration. They have the 4 tabs at the bottom. They have the instructions in the construction tab. They have the tables tab. And then they'll have the computational tab. So I'm not going to go and look at all of the other tabs again. I'll just show you this one here, which is the one that has the graphics. So here, this is the decision site distance tab. Lacey, who is very graphic oriented, also felt cars would be helpful in our graphics. She's probably correct on that. I just had numbers and lines, so you can thank her for gussying it up a little bit. But this one, for example, would just tell you how you calculate decision site distance. One of the issues that we did struggle a little bit with is, in many cases, for, say, corner clearance versus decision site distance, the measurement point is different, and we want to make sure people were aware of that. And then in the access management application guidelines, we actually have a very complex graphic that shows the different measurement points you sometimes have from an intersection. So, for example, for the total design decision site distance you see here, we had to the center of this driveway as an example. Say if this was an intersection and we were doing corner clearance, we would actually have it measured from the extended curb. And then we have content in the document that that's the traditional one, but there's other ways you can measure it. So here, for example, in this one, you can see we have input variables again. Here it's design speed and perception reaction. Then it will calculate for you the perception reaction time. It has input variables for percent reduction in speed, these are operational input variables, and deceleration rate. And then it calculates for you your minimum decision site distance, and then populates our little graphic over here. So I have all of the spreadsheets loaded up. I don't know that it's necessary. You're not going to get a chance to play with them unless you want to come up and use this computer, but they are available on the USB/DVD that can be acquired with the AMAG and or with the combined linked documents. And I'd be more than happy to answer any questions or let you go to lunch early. I'll answer some questions if there are any. None? Yes, Phil.
The other, what am I thinking? The change in the left turn decel that Kay did at TTI. Have you been able to bring that in? It's what, NCHRP 740 something?
Yeah, I don't recall you were on that panel though, weren't you?
Repeat the question.
Oh, I'm sorry. So the question was, Kay Fitzpatrick at TTI, she, I think it was Virgil that was on the panel, now that I think about it, yeah. She completed a project about 4 years ago, and that was on how you can warrant the need for left turns. And in that she had a variety of things. It was a probability-based tool. So what's the probability of a car being in that location? And it was to kind of take a fresh look at Harmalink's work, which was many, many years ago. And she did, in fact, make some very contrary recommendations for it. So what we did is we used standard methods. We didn't actually have, actually had, to be honest, I had a drafter for a report by then, but I didn't have the final report. And I knew that she had pushback from one of her panel members, so we didn't incorporate it in this. Just the timing didn't work out. But we did have a chance when we were editing the AMAG to actually point to it at that time. But the spreadsheet tools, I don't think that we incorporate it, but what we did do is just make them flexible for someone to be able to incorporate it.
You didn't do warrants in this, did you?
No, this is just simple calculations.
You gave them a good graphic information how to design it. So the other thing, because I was very interested because she came up with a turning movement of 5.
Yes.
For armor like this, 50, 75, 100, and it's a real shift. So I'm just very interested in anything that helps remind everybody that there's some research out there that puts that left turn trigger at 5, which we've never gone to before.
Yeah, so that's absolutely right. It's a very, very, very small number, almost so small that almost, I was asked her what would be a condition where someone wouldn't need a left turn was my question when I saw how low the number was. But it is probability based, and you know, the question is, would you have a conflict there? And it's a safety issue. And the answer is yes. And so it's an interesting study, but this was just like the mechanics of doing the calculation. We didn't step into the warrant world, but that's why we were able to give it a nod in the AMAG. We showed the Harmalink as well, and we just showed them both. Yeah. All right. Anything else? All right. Thank you.
Oh, we got one
wait.
more.
Got one more.
We're in stoppage time. We have one more question.
Oh.
Decision side distance drive, what's the purpose for these for the through traffic? You can see the driveway or?
Well, decision site distance to me is if
repeat the
there's,
question. What is
oh yeah,
the
what is the
purpose?
purpose of the decision site distance? Is it for the driver? Is that what you said?
This is for the driver to
Yeah.
find the driveway, right? It's not for the driver vehicle through the gap for the through traffic. That's an intersection side distance.
Right.
This is different thing.
Right, so the question was, what, is it for the driver's perspective, or it's not for the people pulling out of the intersection? And the answer is absolutely. That's why I have the cars shown on the road instead of showing pulling out of the driveway, is because it's to try and represent that probably the most common decision site distance is the unexpected brakes of the car that's turning. Or it could be the driveway itself if no car is turning. That's always an interesting question too. So yes, that was the purpose, was specifically for the driver's alertness to the access point.
Intersection side distance typically will be longer than these.
Yeah, intersection site distance is, there's a place they actually cross, is somewhere around 47 or 48 miles per hour. So intersection site distance will typically be longer until you get to very high speeds. And then they actually reverse just a little bit. It's kind of an interesting phenomenon. One that we ask them to look at when they're looking at the intersection site distance, again, to see if they can figure out why that's happening. All right, thank y'all.
Thank you, Karen.